Now, factoring special cubes is something that tends to not be taught a lot in high school, and then when you get to university calculus, they kind of expect that you know it. So there's a little bit of a gap there between grade 12 pre-calculus, where we don't do special cubes and these aren't formulas that you memorize, and then all of a sudden you get to university and they kind of expect that you've seen these before and know how to deal with them. Now, if you were asked to factor x cubed minus y cubed or x cubed plus y cubed, chances are it would have a number here. Maybe they'd ask you to factor x cubed minus 8. You could do that with the factor theorem that we reviewed yesterday and synthetic division. It would work, but these things come up quite often. Well, not quite often, but they do appear every once in a while. So they're nice to have as special formulas. So these, again, there's no formula sheet this year. All of your formulas you need to know. And so we'll review them all the way through, and we'll practice things that we've had from grade 12 and point out certain formulas that you're going to need to know. And these will be two of the formulas that you'll need to know as well. The way that I like to remember them, the difference of cubes, I remember that it has x minus y. Again, if I was going to multiply this out, when you multiply x times x squared, you're going to get x cubed. So you know that it's going to need to have an x squared there. And if we look at our very last ones, y times y squared, well, that we need to have a y cubed. In the middle, everything needs to cancel out. So if you actually multiply this out, the x gets times by the x squared, the x gets times by the xy, and the x gets times by the y squared. Then in red, the y is going to times by the x squared as well, and the xy, and the y squared. Notice a couple things are going to happen. And it's going to give you a hint that this needs to be a plus sign. Because in order for things to cancel out when you multiply this all out, some of them are going to need to be positive, and some of them are going to need to be negative. So notice that when I multiply, for example, the x times the y squared, can you see that I'm going to get an xy squared? So when I multiply the negative y times the xy, I get a negative xy squared. And those would cancel out. Similarly, if you look at what happens when you multiply the negative y times the x squared, you get negative x squared y. But when I multiply the x times the xy, I get a positive x squared y. So as far as these formulas go, maybe it helps you memorize them. The fact that you've got x cubed minus y cubed for factoring a difference of cubes, you start with an x minus y, then this sign is positive. But when you're factoring a sum of cubes, x cubed plus y cubed, you start with x plus y, but now this sign has to be opposite inside so that that kind of cancellation happens. So we're going to see these formulas come up in a few of our questions. What we're doing is we're developing a sense of all the things that you're going to need. So when we get to our limit questions, one of the main strategies for solving limits will be using factoring, and we'll be able to use this to help us solve those. So here, we're going to factor a couple of the difference of cubes and sums of cubes. What you have to recognize, while x cubed is easy to see that that's a cubed, can you recognize that 8 is a cubed? This is the same as x cubed minus 2 cubed. And if you can recognize that, well, now we can factor. It's going to be x minus 2. We're going to have the first one squared here, the last one squared there, and because it's the minus 1, it's plus 2x there. Again, if we look back at our formula, our formula looked like this. And so now x is x, but the y is actually the 2. So we just need to plug things into the formula accordingly. The next example, if we look at the sum of cubes here, we have to recognize the first one's easy to see that it's a perfect cube. Can we see that the second one is a perfect cube? What would it be in there to make a perfect cube? I need a 3 to get the 27, and I need a b squared to get the b to the 6. And now we can go to our formula. It's going to be x plus y, so it would be a plus 3b squared. The first one squared will be here. The last one squared would be there. This time it's a negative sign of x times y, so this would be 3ab squared in between.